Hey everyone, welcome back. Today, we're diving into a brand new explainer that acts as your ultimate guide to mastering one of the most powerful yet sometimes totally infuriating AI generation tools out there, ComfyUI. Whether you're building complex AI art tools or automating full-on video creation, ComfyUI is absolutely incredible. But let's be real, that learning curve, it is steep. So today, we're figuring out how to transform all those complex back-end setups and frustrating terminal errors into a really clear, actionable roadmap. I mean, we've all been there, right? Have you ever spent literally hours meticulously dragging and dropping a massive workflow, connecting every single little line, only to hit an absolute brick wall of red text? Or maybe you find yourself constantly reinstalling the exact same tools every single time you boot up the cloud. It is beyond frustrating. But today, we're going to look at this through the framework of a builder's journey. We are going to construct your AI environment from the ground up, the right way, so you can finally stop wrestling with the software and just start creating. So here is our quick roadmap for today. We've got 4 stops. Number 1, infrastructure setup. 2, models and licensing. 3, nodes and logic. And finally 4, troubleshooting. All right, let's jump right into section 1, infrastructure setup. We're looking at cloud versus local PC. Right off the bat, there is a clear divide in how you can actually run this software. If you're running it at home on a local PC setup, you absolutely need a dedicated NVIDIA or AMD graphics card. And you need at least 12 gigabytes of VRAM, so think something like an RTX 3060 or better. Now, if you don't have that kind of hardware sitting on your desk, that's when you look to the cloud. You can use platforms like RunPod to essentially rent a virtual hardware environment packed with massive computing power. But if you are using the cloud, there's a massive pain point we need to talk about. Are you just completely tired of reinstalling your workflows and re-downloading these massive 40 gigabyte models every single time you boot up RunPod? It eats up so much of your time, not to mention your budget. Okay, so the absolutely crucial fix here is establishing persistent storage. Here is exactly how you set this up so you only have to download things once. Step 1, just navigate over to your RunPod storage section. Step 2, create a new network volume. And step 3, attach that volume to your rented GPU, maybe something like an RTX 6000. By doing this, you are essentially renting a virtual hard drive that saves your models and your progress permanently, even when you turn the whole machine off. Next time, you just drag, drop, and get straight to work. So realistically, how much storage do you actually need? Well, if you look at really heavy video generation models, like WAN, for example, those guys easily take up around 48 gigabytes per model. So if you plan on actively working with about 3 different models at any given time, you're going to want to recommend a network volume of roughly 150 gigabytes. Oh, and quick tip, if you aren't doing long-term work with a specific model, just delete it. Save yourself that space. Moving right along to section 2, gathering materials. Let's talk about models and licensing. You basically have 2 main pathways you can walk down here. First up, open source models, things like Flux or WAN. These can be run locally or on your rented cloud server for absolutely free. You do not pay per image. On the flip side, we have API-based models, and they are going to constantly ask you for credits every single time you hit that generate button. So if you've got the hardware or the cloud space ready to go, open source is definitely the way to dodge those annoying per-generation credit fees. But wait a second, because open source doesn't always mean a total free-for-all. Let's look at model licensing. If you download a model and check its page, say over on Hugging Face, and it says Apache 2.0, you are golden. It's fully open and commercial use is totally allowed. You could literally build a back-end service and sell access to it. But if that license says other or restricted, you really need to be careful. A lot of those are strictly for research purposes only. You absolutely cannot build a company around them, and you cannot host them on a commercial website for clients without facing a massive ban. Always, always check the license. And hey, while we're talking about hosting for commercial use, let's clear up a huge misconception. You cannot just slap these AI models onto standard web hosting like GoDaddy or Hostinger. That will not work. Standard web hosting just provides storage for basic media files and text. These heavy AI models require a dedicated inference server. They need an active, powerful computing environment. You have to build the workflow on something like RunPod to act as a backend, and then connect your shiny front-end website to it. All right, on to section 3, construction. We are breaking down workflow nodes and logic. When you look at any workflow, you're constantly going to see a node called VAE, which, let's be honest, sounds pretty confusing. It actually stands for Variational Autoencoder, but you can just think of it as a translator. See, when the AI generates an image, it creates it in this highly compressed mathematical form that our human eyes just can't comprehend. The VAE decoder steps in and translates all that raw data into the visible pixels you actually see. And if you're doing image-to-image work, you need a VAE encoder to translate your starting photo into computer data and a decoder to translate it back out at the end. Now, right next to that VAE, you'll almost always see a connection to the latent space. The absolutely crucial thing to grasp here is that latent space dictates the specific size and resolution of your output. This is essentially where you tell the workflow, hey, I need a canvas that is exactly 512 by 512 or 1024 by 1024. It sets the strict physical boundaries for the generation. And that brings us to our final stop, Section 4, Maintenance. Troubleshooting common errors. Okay, picture this. You've built your masterpiece workflow, you hit Q prompt, and boom, error. This brings us to perhaps the most notorious roadblock for beginners, the dreaded 0-byte file. You tell your AI agent or your terminal to download Alora, it happily says successful, but when you check the folder, it shows exactly 0 bytes. Like, why does this actually happen? Well, the 0 bytes error happens for a couple of sneaky reasons. Mostly, it means only the outer shell of the file managed to download, but the actual internal data or the required dependencies completely failed to pull through. Your AI agent might look at the terminal, see the text saying download complete, and just tell you it was a huge success, totally blind to the actual file size. The fix? You need to run verification commands in your terminal. Just ask your AI assistant to verify if everything has been completely downloaded, and it will hand you a script to double-check the actual file integrity. Here's another incredibly frustrating one. You open up a workflow you just downloaded, and a pop-up tells you to download missing models. You click yes, it downloads, you refresh, and the exact same pop-up appears right back on your screen. Maddening, right? This happens because the underlying custom nodes haven't actually been installed yet. The system is just stuck in a loop. The golden rule here is this. Always go to your manager, click Install Missing Custom Nodes first, let that entirely finish, and then, only then, run your model downloads. And guys, this is exactly why understanding the nuts and bolts of your nodes matters so much. If you ever get hit with a purple runtime error saying your inputs don't match, you are usually dealing with an architecture mismatch. You simply cannot mix and match models from different families. If you're using a specific text encoder but trying to pipe it into a completely incompatible VAE, the whole system crashes. The dimensions just do not fit. You have to ensure that your text encoders, your models, and your VAEs are all natively built to speak the exact same language. We have covered a ton of technical ground today, but I really want you to take this quote to heart. When you inevitably hit a wall in ComfyUI, don't just paste the error into an AI and blindly copy the fix. If you ask the agent why the error is happening instead of just asking for a fix, you will gain much more clarity. Seriously, this tiny shift in mindset turns debugging from a miserable chore into an absolute masterclass of its own. So, armed with the right infrastructure, a rock-solid grasp of licensing, a clear understanding of your nodes, and a completely new, proactive approach to debugging, are you ready to build your next ComfyUI workflow without the headache? Your tools are all set up. Your canvas is totally blank. What impossible idea are you going to bring to life first? Thanks so much for joining me on this explainer, and hey, happy building!